Uh, in this lecture, we will discuss about the relation between beta and gamma function. Relation between beta and gamma function. So we have the relation. So we prove this relation also. So to prove that beta mn is equal to gamma n upon gamma m plus n. Okay, so this relation will valid when m and n greater than 0. Remember this. So this is our relation between beta and gamma function. So beta mn is equal to gamma n upon gamma m plus n. So we prove this result. So proving this result, so we take the definition of gamma function. So by using the definition of gamma function, so we use the definition of gamma function. So we write down as gamma m. So first is gamma m, then gamma n. So we write down gamma m is equal to integral 0 to infinity e raised to the power minus t. We take the variable t and t raised to the power m minus 1. T raised to the power m minus 1 into dt. Okay. So generally we remember the definition in this form. Gamma n is equal to integral 0 to infinity e raised to the power minus x raised to the power n minus 1 into dx. But here we write this into variable of t form. Okay, so we take the variable t here. Now, for proving this result, so we put t is equal to ax. So here we put t is equal to ax. So we take the differentiation of this. So dt gives us a into dx. So a into dx. Now we talk about the limits. So we talk about the limits. So when we put a lower limit t equal to 0, so 0 is equal to ax. So here we can see that the x equal to 0. When we put a upper limit infinity, so that means t equal to infinity. So infinity equal to ax. So this we see that infinity upon something gives us infinity. So limits remains unchanged. Okay. So we write down this as gamma m is equal to integral 0 to infinity e raised to the power minus t. T is ax. E raised to the power minus ax into ax raised to the power m minus 1 into dt. Dt means a into dx. So a into dx. So this can be written as integral 0 to infinity e raised to the power minus ax, a raised to the power m minus 1 here and a this. So we can write down as a raised to the power m into x raised to the power m minus 1 into dx. So x raised to the power m minus 1 into dx. So now we write into this form. So this is our equation number 2. So this is our equation number 2. Okay. So we do one thing for this also. So we change the variable a into z. So changing a to z or a by z in equation 2, we see that when we change this a by z, so we write down this as gamma m is equal to integral 0 to infinity e raised to the power minus zx z raised to the power m into x raised to the power m minus 1 into dx. So this we can use as equation number 3. Okay. So we do one thing here. So we multiply both side, by e raised to the power minus z and z raised to the power n minus 1. E raised to the power minus z or z raised to the power n minus 1, and integrate and integrate with respect to z. Integrate with respect to z. With respect to z by taking limits, by taking limits 0 to infinity. 0 to infinity. So here in LHS side, so first we talk about LHS side. So we see that gamma m into, we take the integral 0 to infinity, and we write down this as e raised to the power minus z raised to the power n minus 1. When we integrate this, so we write down dz. So this is our LHS side. Now we talk about the RHS side. So for RHS side, we see that the given in this integral in the form of x. So we take the term of x into this side, so this dx, and second integral we can take for z, so 0 to infinity for z, or when we multiply this in, we can write down as zx into z raised to the power m, or multiply जब करेंगे, so this can be written as, this can be written as e raised to the power minus z or z raised to the power n minus 1. So into dz. So we are integrating with respect to z also. So into dz. Into dz. So we simplify this term. So here in LHS side, we do this thing. So that means this is the definition of gamma function. So this is the definition of gamma function. So definition of gamma. So here we use the definition of gamma. So this is equal to gamma n. So we write directly gamma m into gamma n is equal to integral 0 to infinity x raised to the power m minus 1 into dx, or this integral. First we simplify this as 0 to infinity. Here we have the variable, that means the base is e, so we can add the power. So we can write down as e raised to the power minus 1 plus x into z, and second, here we have z raised to the power m or z raised to the power n minus 1. So we write down z raised to the power m plus n minus 1 into dz. Into dz. Now we solve this integral. So first we solve this integral. So when you solve this integral, so by substituting the value of z into 1 plus x is equal to y. So we solve this integral, z into 1 plus x equal to y, and what is the value of dy? So dz into 1 plus x equal to dy. So value of dz you can write down as dy upon 1 plus y. Okay, so dy upon 1 plus y. For talking about the limit, so limit when z equal to 0, so y equal to 0, or z equal to infinity, y equal to infinity. The limit remains unchanged. Z equal to 0 gives us y equal to 0. Z equal to infinity gives us y equal to infinity. So this you can write down as integral 0 to infinity x raised to the power m minus 1 into, limits remain same, and this can be written as e raised to the power minus y, or second. So in place of z, we can write as y upon 1 plus x. Y upon 1 plus x. So we can write down as y upon 1 plus x in place of z, and power m plus n minus 1 into dz. The value of dz is dy upon 1 plus y, okay, into dx. You can write down as, now integral 0 to infinity x raised to the power m minus 1. We simplify this as integral 0 to infinity e raised to the power minus y, e raised to the power minus y, and y raised to the power m plus n minus 1 into dy. So we take this into the integral because we are solving for integral y, and the powers of 1 plus x. So 1 plus powers of 1 plus x. Okay. We do one change here. So this is 1 plus x here. Okay. dz equal to y upon 1 plus x. So this is 1 plus x, 1 plus x. So this is 1 plus x. So note down as 1 plus x raised to the power m plus n minus 1 and 1 plus x. So this gives us 1 plus x raised to the power m plus n into dx. Now, the value of this, again we use the definition of gamma. So we use the definition of gamma function. So here this equal to gamma m plus n. This will equal to gamma m plus n. So we write down this as integral 0 to infinity x raised to the power m minus 1 upon 1 plus x raised to the power m plus n into this value is equal to gamma m plus n. Gamma m plus n. Or we write down this as into dx. So gamma m plus n taken outside, and this can be written as in 0 to infinity x raised to the power m minus 1 upon 1 plus x raised to the power m plus n into dx. So this will be equal to the beta mn. So by using property of beta function, so this can be written as gamma m plus n into beta m n, और LHS क्या है? LHS is gamma m gamma n. So we write down as beta mn. Beta mn is equal to gamma m gamma n upon gamma m plus n. So this is our proof. Okay. So this is the relation between beta and gamma function. So we will solve the problems by using this relation. Now we move to the another properties, or we can say that the deductions. So to prove that integral 0 to pi by 2, integral 0 to pi by 2 sine 2m minus 1 into theta cos 2n minus 1 into theta d theta is equal to gamma m gamma n upon 2 gamma m plus n. So we will prove this result by using previous property. That means in previous lecture we have discussed this property. So this value means LHS side is equal to beta mn. So we prove this. So we know that, we directly write down as, we know that beta mn, is equal to twice of integral 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta into d theta. Okay. So we have proved the relation between beta and gamma. So use using a relation between beta and gamma function. Relation between beta and gamma function. So we put the value of beta mn. Beta mn value is gamma n upon gamma m plus n. So this is equal to twice of integral 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta into d theta. Okay, so we can write down this result as hence integral 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta is equal to gamma n upon gamma m plus n into 2. So this is our proof. Now we can extend this result. So when we extend this result by putting 2m minus 1, by putting 2m minus 1 is equal to p and 2n minus 1 is equal to q. So then we get integral 0 to pi by 2 sine raised to the power p theta cos raised to the power q theta into d theta is equal to so when we put 2m minus 1 is equal to p, so what is the value of m here? So the value of m here p plus 1 by 2. So we can write down the right RHS side is, so this can be written as p plus 1 by 2. And what is the value of n here? So a value of n is q plus 1 by 2. So q plus 1 by 2 upon 2 gamma p plus 1 by 2 plus q plus 1 by 2. So now we simplify this. So we write down this as integral 0 to pi by 2 sine p theta cos q theta into d theta is equal to gamma p plus 1 by 2 gamma q plus 1 by 2 upon 2 gamma p plus q plus 2 p plus q plus 2 by 2. So this is our further result. Okay, in many questions we also use this result directly. Now we have one more result. So when we put p is equal to 0 and q equal to 0, so then we see that the integral 0 to pi by 2 sine into 0 theta cos 0 theta d theta is equal to gamma 0 plus 1 by 2 gamma 0 plus 1 by 2 upon 2 gamma 0 plus 0 plus 2 by 2. So first gives us gamma 1 by 2, second also gives us gamma 1 by 2 upon 2 gamma 2 upon 2. The 2 upon 2 means gamma 1. Gamma 1 is 1. So we write down this as integral 0 to pi by 2. So sine raised to the power 0 means 1, cos raised by 0 1. So this is theta, d theta, or numerator we can write as gamma 1 by 2 to the whole square upon 2 gamma 1. Or gamma 1 is 1. So we know that gamma 1 is 1. So this can be written integral 0 to pi by 2 d theta is equal to 1 by 2 into gamma 1 by 2 to the whole square. 1 by 2 to the whole square. Now we evaluate this integral. So this gives us theta. Apply the limit 0 to pi by 2 into 1 by 2 of gamma 1 by 2 to the whole square. So this equal to pi by 2 minus 0 is equal to 1 by 2 gamma 1 by 2 to the whole square. So pi by 2 equal to 1 by 2 into 1 by 2 to the whole square. So 2 to 2 cancelled. So this equal to pi equal to gamma 1 by 2 to the whole square. So hence we can calculate the value of gamma 1 by 2. This gives us root pi. Okay, so we can prove gamma 1 by 2 equal to root pi by using this also.